Welcome to the NuWave product announcement at Bootcamp 2021. My name is Casey Krasner, the Director of Revenue for NuWave Technologies, and today I am joined by Dave Beliveau, our CTO and the Chief Architect for all NuWave solutions. We are extremely excited to discuss this topic and announce our product. We have been working on it for quite some time and truly believe that this is the next step in web service integrations for the HPE NonStop. Before we discuss where we are going, we believe it is important for us to discuss where we have been. We are the leader in nonstop middleware and web service integration, and we currently offer two solutions that enable REST services on the NonStop platform, both Lightwave Server and Lightwave Client. Both solutions are middleware that run entirely on the HPE NonStop servers in Guardian. They provide REST web services to expose and consume RESTful APIs connecting middleware endpoint services. Lightwave Server is server-side middleware that enables you to expose your NonStop applications as REST services, while Lightwave Client is middleware that enables you to access REST services from your NonStop. When REST is available, we allow you to connect your HPE NonStop server to share and consume information virtually anywhere on any platform. RESTful APIs are widely used in almost every industry. There are currently 12,000 APIs offered and used by companies today, and that is just in the financial industry alone. Services that are available through these APIs account for roughly 75% of many large companies' revenue. For example, Salesforce generates 50% of its revenue through RESTful APIs. eBay, roughly 60%, and Expedia.com generates a total of 90% of their total revenue through the use of services that they would not have access to without an API in place. APIs can give you a competitive edge by connecting internal and external services that provide added business value to your company. APIs are becoming critical components of the enterprise infrastructure and application architecture. As we know, the NonStop is the always-on, always available solution, even when other parts of the enterprise are not available. It only makes sense to have our critical infrastructure supported and run on the most reliable platform in our enterprise. And this is what makes having an API gateway on NonStop a perfect pairing. We are proud and excited to announce NuWave Prizm, the NonStop-based gateway for all of your APIs. Prizm Gateway is a browser-based interface that makes it easy for users to enable, maintain, monitor, and secure API connections throughout the entire enterprise. Prizm Gateway is a software that sits in front of one or more APIs. Since APIs act as the entry point for applications to access data from your backend services, with a Prizm Gateway in place, you can connect all of your RESTful APIs to enable real-time communication for applications. Prizm Gateway provides a single point of entry by accepting and processing all API calls while enabling traffic management, DOS protection, authorization and access control, A/B deployment, and monitoring. Prizm Gateway takes all calls from any client, determines which services are needed to fulfill those backend requests, and combines the necessary calls to one or more backend services into a unified, seamless experience for the user. Prizm Gateway acts much like most enterprise gateways, such as MuleSoft, Kong Gateway, or API Gateway, to name a few. Prizm Gateway will separate your external APIs from your internal service APIs, allowing for services to be added and boundaries to be changed with minimal impact and effort. The result is the ability to refactor or resize your services over time without negatively impacting your externally bound clients. It will prevent malicious attacks, such as a DOS attack, by providing limitations to all calls that pass through the gateway. Services and microservices have many common concerns, such as authorization using API tokens, access control enforcement, rate limiting, and these are just a few. Each of these can add more time to development of services by requiring that each service implement them individually. Prizm Gateway eliminates these concerns by providing these services for all connections that pass through the gateway. From here, I'm going to hand things over to Dave, who's going to take us on a deep dive into the features of Prizm, as well as a walkthrough of the product.
Thank you, Casey. Yes, we're going to take a quick look at the features of Prizm Gateway, and then we'll take a look at a few use cases, and we'll finish up with a quick tour of the management console. So let's start with NonStop fundamentals. Prizm Gateway provides a single point of entry into your application universe. By providing a single point of entry for all APIs, we're able to provide added security and manageability for your enterprise applications. The product is Guardian-based. There's no need to have OSS or any additional software installed. Everything you need comes with it, and that can make installation and management much simpler. It is, of course, fault tolerant on the NonStop platform. This is expected, and this eliminates the risk of downtime with its dual redundant hardware and system software and application software that is robust and self-healing. For management, we provide two user interfaces. One is the web-based graphical user interface, which is modeled on our current Lightwave products. If you're a Lightwave user, you'll find these very familiar. Provides a comprehensive management of the entire set of features. And we find that the graphical user interface allows for a very short learning curve. So there's much less time and money spent getting users up to speed. The command line interface for basically for use in Tackle as a COM program, which we're all familiar with, allows you to configure the gateway and manage the gateway using the Tackle command line, or more importantly, you can script or use Tackle macros to manage the gateway or to automate the management of the gateway. And this can be really helpful when you're automating deployments or transitions between development and QA and production environments. And of course, there's logging and diagnostics that helps you monitor the health of the gateway and helps resolve any functional issues that you might run into. The gateway provides a couple of client authentication options to start with. HTTP basic authentication is provided. That's simple username and password authentication. And we're also providing JSON Web Token or JOT or JWT authentication, which is much more comprehensive and is becoming quite popular. And down the road, I'm sure we'll be adding additional authentication options. The gateway provides a number of DOS protection features or denial of service protection features. The first one, rate limiting, we'll be looking at a use case for that, and that allows you to limit the number of requests that are coming into the gateway and passed up to an upstream service that can prevent overloading of the upstream service. Connection count limiting, which can limit the number of connections coming into the gateway with active requests. Request size limiting, which can limit the size of requests coming into the gateway. You can prevent a malicious attack by a user who's sending gigabytes of data to your service when the service only expects a small request. And IP address restriction, which allows you to limit access to known good IP addresses or prevent access from a specific range of addresses that you don't want to provide access to. We provide load balancing. Load balancing allows you to distribute the load of the incoming requests across a number of backend servers, physical servers. And canary deployment. It's an interesting name for a deployment method where you gradually shift traffic from an older version of a service to a new version of the service, and that provides the ability of shifting back to the previous version if problems arise, and we'll be taking a look at a use case for that as well. So as you can see, the features of the gateway are quite extensive, but there's always the added benefit of running on the NonStop, fault-tolerant, mission-critical, always-on platform. So let's take a look at how most current NonStop environments look today without an API gateway, and then we'll dive into where the gateway fits into the enterprise. So in many current API environments, We have front-end clients that need to utilize back-end services. And you may have all of these clients making one-to-one connections here and there and all over the place. And they basically do whatever they have to do to get to that back-end service. If we apply this to a more specific use case, such as a banking application, we might have a mobile or web-based application or ATM clients accessing multiple back-end services on multiple physical servers. And while this may work, there are a number of problems that can arise. You've got countless entry points into the back-end servers and services that store critical information. This creates risk and impacts security, operations, and development resources because each service would need to implement its own DOS protection and authentication mechanisms. Each service would need to implement its own upgrade strategy. If a change is made to a backend service, there has to be a strategy in place to upgrade the clients and the backends to the new version, and that's costly and time consuming. Each service would need to implement its own load balancing mechanism where necessary, and that's also costly and time consuming. So if we take this use case and insert an API gateway, and ideally we would make it the NuWave Prizm Gateway running on NonStop, we can avoid a number of potential problems because we've provided a single point of entry for all communications between front-end clients and back-end servers. We've added a central point for DOS protection or DOS protection and authentication. We've added a central point for service load balancing. We've added a central point for service upgrade, in our case, using the canary deployment method. And we've made life a lot easier for our security, operations, and development staffs because they don't have to implement any of these features in the individual services or microservices. And we've done this, of course, on a robust, fault-tolerant platform like the NonStop. And while the gateway can be used in an application-specific scenario, such as the banking use case, the gateway need not be limited to a specific application or just one application on the NonStop. The gateway runs on the NonStop, but it can act as a gateway to services both on and off the NonStop. In this illustration, we've got our NonStop running base 24 or in a database application or a microservice, but the gateway is also providing access to off NonStop services such as an SMS service or a currency conversion service or one of the many thousands of services that are available on the public internet. Okay, so let's take a look at a DOS or a denial of service attack use case. In this case, we've got a number of clients contacting one or more web services, and one of those clients decides to go rogue. And it begins to send hundreds or thousands of requests per second to a service that's sized at a much lower transaction rate. And that results in the service really slowing down. And that makes it inaccessible to legitimate clients. And there we have a denial of service. To provide protection against this threat, we can configure the gateway to rate limit requests to that particular service. For example, if we set the rate limit for the service to 10 messages per second per client IP, that's it. That's how many messages we'll be able to access the gateway or the backend service from that client. So if a client tries to send more than that, the request will be stopped in the gateway and any malicious attempt to overwhelm the service will be denied. This allows legitimate clients to continue to interact with this service. And this is an example of rate limiting, but our other DOS protection methods, again, can be used to limit what client IP addresses can access the service, limit how many connections the client can make or a service can accept, and limit the size of requests so a service isn't going to be overloaded by a rogue client that's sending enormous messages to a service that only expects a small one. Load balancing is a fairly well-known scenario. You can configure the gateway to balance client traffic between multiple backend servers by using logical load balancers within the gateway. This allows services to be added or removed based on application traffic changes or when servers need to be taken down for maintenance or upgrade. And then canary deployment, again, is a technique used to stage the release of a new version of a backend service. So clients, in this example, clients are currently using version 1 of the service and version 2 is brought online. Then a small percentage of the traffic is directed to the new service. And then those clients are closely monitored for any problems. If some issue arises, then all of the clients can be routed back to the existing version very quickly. If no problems occur, the traffic to the new service is slowly increased until all clients are using version 2, and ultimately version 1 can be retired. So again, here's our list of gateway features, our comprehensive list. I won't go through them again, but if you would pick up a copy of our data sheet, they're all listed there to remind you. So let's move on and take a look at a block diagram for the internal architecture of the gateway. And this shows how traffic flows through the gateway. In this diagram, traffic would be flowing from left to right, from the client through the gateway to the backend service. The first thing we find in the gateway is a listener. Listeners define what TCP/IP ports the gateway will listen on, and defines the properties of those ports, such as whether the port supports TLS or HTTP2, what TLS protocols are supported, and traffic flows into the gateway through listeners. Then we define services, which define the backend web services that the request will ultimately be directed to when traffic flows out of the gateway. We have routes, which bind listeners to services, and routes define which services a request will be routed to based on the various attributes of the request, like the URI or the method or a header value. We have plugins which apply features such as DOS protection and authentication to traffic flowing through the gateway. Plugins can be applied to specific routes or services or globally to all traffic flowing through the gateway. And finally, load balancers. Again, some services may send traffic directly to a single backend service, or the traffic may be directed to an internal load balancer, which will distribute the request to multiple backend service instances. So let's take a quick look at the console, the management console. If you are a Lightwave user, this will look very familiar, at least the look and feel will look familiar. After signing in, you're presented with the dashboard. The dashboard in this screenshot is fairly simple at the moment, but ultimately, the dashboard will contain all kinds of information about the status and health of the gateway. The side menu provides access to various configuration options for both the gateway and the gateway management users and groups. So to begin configuring a traffic path through the gateway, we begin by defining a listener. And we do that by selecting listeners from the menu and clicking the button that allows you to configure a listener. And we configure parameters like the TCP/IP port for the listener, whether or not the port supports TLS and HTTP2, and the protocols that we're going to support on that port. Next, we define the backend service. And here we're defining the service endpoint address and optionally the path, which will act as a prefix for the requests going to that backend service. In this example, we're using the JSON placeholder test service, which is a free third-party web service out on the internet. So this is actually an example of the gateway routing requests off the NonStop, requests coming into the NonStop, but they're going out to a service on the public internet. Next, we're going to bind a listener to a service by creating a route. And here we are defining a route with the path posts and users, which will result in any request coming into the gateway through our listener with a request URI starting with posts or users to be routed to the JSON placeholder test service. And then we're going to add a plugin to the service. For example, the rate limiting plugin from the example given earlier. In this example, we're going to be setting the rate limit of 20 requests per minute or once every 5 seconds per client. And finally, if we intend to use a load balancer, we first configure the load balancer. And in this example, we are going to configure the load balancer to balance between 2 instances of the backend JSON placeholder test service. Once the load balancer is configured, we would return to the service screen and configure it to use the load balancer instead of a direct connection to the backend service. And that's pretty much it. That is a quick walkthrough of the UI. If you have any questions at this point, please enter them into the chat area or the question area, and we'll do our best to answer them right away. And at this point, I'm going to hand things back to Casey. Casey, take it away.
As you can see, Prizm Gateway provides peace of mind by acting as a single point of entry to the enterprise for all of your APIs. We are excited to announce that Prizm Gateway will be coming to the NonStop in Q1 of 2022. When it is released, Prizm Gateway will be a fully feature-rich gateway with all features that we have discussed here today. If you'd like any additional information about Prizm, please reach out to us at info@nuwavetech.com or visit our website. Thank you all for joining us during these exciting times here at NuWave Technologies. We look forward to working with you and your team to implement Prizm Gateway in your enterprise.